We're going to take a look at number 23 from section 7.4, linear inequalities in two variables. 23 provides us the following system of inequalities. We have 3x plus 6y is less than or equal to 6. Then we also have 2x plus y is less than or equal to 8. So as we had previously done in with other examples, we want to go ahead and get these into a slope-intercept form. And then graph them one at a time. So I will go ahead and do the first equation in the system in blue. So we'll have 3x plus 6y is less than or equal to 6. And again, when you are asked to get something into slope-intercept form, we want to isolate the y on one side of, in this case, the inequality. Divide everything by 6. Note that we're dividing by a positive number, so the inequality sign will not change. Then this negative 3 over 6 will simplify down to a negative 1/2 x plus 1. So let me go ahead and get some tick marks on my x and y axes. So the way that this reads, I'm going to start at point 0, 1, because that is where my y-intercept will be according to my slope-intercept form. And then I'm going to move down 1 to the right 2. And I can continue to do that until I feel comfortable, until I feel like I have enough points in order to safely plot the point, to plot the line out. Also note that I can go down 1 and to the right 2. I can also go up 1 and to the left 2. That is also an option. Okay, and because I'm working with an inequality sign that is less than or equal to, that's going to tell me that the line that I will use to connect my points will be solid. Okay, so now we need to check to see which side of this inequality I need to shade on. So I'm going to pick a point that is not located on the line. So in this case, I'm going to pick the origin because it's pretty easy to work with and fairly quick to solve. So you can either use the equation or the inequality the way that it was provided for you, or you can go ahead and work off of what you have after you get it into slope-intercept form. So I'm going to go ahead and just use the original form just because I think the calculations will go a little bit quicker. 3 times 0 is 0, 6 times 0 is 0, and 0 plus 0 is 0. So we get this statement that says that 0 is less than or equal to 6. That is true, so I'm going to go ahead and shade on this side of the line. Next, we'll take a look at the second inequality in the system. So we have 2x plus y is less than or equal to 8. Subtract 2x from both sides. And we are left with y is less than or equal to negative 2x plus 8. So, let's see here. Our y-intercept is going to happen at 0, 8. And then I'm going to move down 2 units and to the right 1 unit. We can do that because we can write negative 2 to make it look like a fraction. So the top portion of the numerator is a negative 2, which would tell me to move down 2. And the number in the denominator, or the bottom part of the fraction, is a positive 1. So that's why I'm going to go to the right 1. And I will continue to do so. And note in this case, again, I have a less than or equal to sign. So that means that my line will be solid again. Connect that. Now we're going to go ahead and check. So we need to decide which side of the line we are going to shade. And again, notice that the origin is a point that is not located on that line, so I'm safe to use it. You can also use something a little bit just as easy, so like 0.11 for example. I'm picking these points with smaller values because it will hopefully make it quicker, or it'll make it quicker to calculate, and it will also free me from potentially making some calculation errors, or hopefully it would. So for the check, we'll have 2 times 0 plus 0 is less than or equal to 8. 0 plus 0 is less than or equal to 8. And we end up with the statement that 0 is less than 8. That is true. So I'm going to go ahead and shade on that side of the line. And I'm going to go ahead and box this in green, or kind of point it out. So everything from this part of the line that we had from the first inequality to this part of the line that we got from the second inequality, everything from beyond that point, this is where your solution lies. And you can justify that by saying that is where the pink and the blue shades overlap. So where there is overlap, that means that those two inequalities are sharing those points as potential answers. So where they are sharing points is where all the solutions are. I hope that helps. If you have any additional questions, please let me know.